Hello. For this video, we are going to investigate integer powers of I. Now, I is commonly referred to as the imaginary constant number, and it is defined as the square root of -1. Now, I squared is equal to the square root of -1 squared. And that is equal to -1. Now, we may ask ourselves, why does the square root of -1 squared equal -1? One explanation is that if we square a square root, we're essentially canceling out the square root. So we're just left with the number that was under the square roots. So in this case, it is -1. Next, let's consider I cubed. We can use a property of exponents to rewrite I cubed as I squared times I. And we already know that I squared is equal to -1. So we can substitute -1 for I squared. So I squared times I is what we have. And if we consider I to be a constant and we multiply that by -1, that equals the negative version of that constant. Or we can say that it is equal to -I in this case. Next, let us consider I to power 4. We can use the same property of exponents to rewrite I to power 4 as I cubed times I. I cubed has been evaluated here to be -I. So we can make a substitution. So we get -I times I. Now, if we multiply I times I, that's the same as I squared. And this negative in the front just appears here as well. So we have -I squared. Now, we know that I squared is equal to -1. So we can write this as -1. And if we have a negative in front of the parentheses, we can actually view this as -1 being in front of the parentheses. So this becomes -1 times -1. And if we consider this as a negative times a negative, it becomes a positive. So -1 times -1 is just +1. So I to the power 4 is +1. Now let's go ahead and review what we have found so far. So we know that I is equal to the square root of -1. I squared is equal to -1. I cubed is equal to -I, and I to the power 4 is equal to 1. Now you may ask, what is I to the power 5? Well, let's check that out. I to the power 5 is actually equal to I. And this is possible because to get to I to the power 5, we just have to multiply I to the power 4 by I. And that is the same as multiplying just 1 by I. And 1 times anything is itself. So we get just I for I to the power 5. This puts us back to where we started. So I to the power 5 is actually equal to the original imaginary constant number. Now, to get I to the power 6, we just have to multiply this by I, and we're just going to get -1 again. For I to the power 7, we get -I, and for I to the power 8, we get 1. And then after I to the power 8, the process just continues, and we have a cycle. So if we want to find any integer power of I, we can just consider this cycle, and it's always going to be one of these 4 values when simplified. Now, we may not be able to go through the entire cycle every time we want to find an integer power, um, because as these exponents get increasingly large, we'll have to go through the cycle increasingly many times. But there is a shortcut that we can use. We can consider that every time we raise I to a multiple of 4, we get 1. So I to the power 4 is 1, I to the power 8 is also 1. And likewise, even if we consider I to the power 12, we're going to get 1 as well. So if we know that, then we can use a multiple of 4 as a benchmark. And then from there, we can just consider what the exponent of I should equal based on the values that we have here. So let's go ahead and check out an example. Suppose we have I to the power 22. So we may ask ourselves, how do we simplify this? Well, to do so, we can just begin with power 22 and just divide that by 4. So we determine the number of cycles that we would need to go in order to get to the 22. But of course, if we divide by 4, we're expected to have a remainder. So let's see what the remainder is. The remainder for this is 2. Now, this remainder is actually going to tell us what power of I this is equal to. So I to the power 22 is expected to equal just I to the power 2. But of course, there's a process that we can use. So let's check that out. We can rewrite I to the power 22 as I to the power 4 to the power 5 times I squared. And this is actually true because of properties of exponents. So if we multiply these exponents here, we get 20, and then we can add 2 to get 22. Now, I to the power 4, we know that equals 1, so this is actually 1 to the power 5. And we're still multiplying by I squared. Now, this simplifies to just I squared. And we already know that I squared is equal to -1. So essentially, I to the power 22 is equal to -1. Now, let's check out some practice problems. Feel free to pause the video to work out these practice problems on your own. All right. So let's go ahead and check this out. I to the power 14 is equal to -1. I to the power 48 is equal to 1. Now let's keep in mind that 48 is a multiple of 4. So we don't have to consider the remainder in this case. We just know it equals 1. I to the power 101 is equal to I. I to the power of 29 is also equal to I. And I to the power of 503, that is equal to negative I. Now, let's consider another scenario. Let's say the power of I that we have is a non-positive integer. How are we going to be able to determine that using the information that we have? Is it possible to work backwards? Well, that is something that you may investigate on your own. And of course, if you have an answer, please feel free to comment your answer below. Thank you.